Alright, after learning all the techniques to evaluate limit, you finally made it to the limit definition of derivative, which is in the yellow box. How do we get over there? So first, we review this graph again. We have a function, f of x, and we have the graph of a function f, so that is a y curve. What I am trying to do is, I want to find the slope of the curve at point P. So first, to do so, I need to start with a secant line. So I drew a green line, a secant line that goes through the curve twice. There are two intersections, one at point P, one at point Q. At point P, my x-coordinate is A, so you plug in A into the function f, you have f of A as the y-coordinate. So the coordinate of point P is A comma f of A. And then to find point Q, at point P, I take h steps forward. So do you see the dashed line? I take h steps forward. So that means the x-coordinate of point Q is A plus h. How do you get the y-coordinate? You simply plug in A plus h into the function to get y-coordinate. So you have 2 points. Look at the third line. You have a white and then you have an orange. A comma f of A and A plus h comma A f of A plus h. So there are 2 points, one at P, one at Q. So what we are trying to do is, I want to find the slope of the function at point P. Having a secant line is not enough, so I need to build a tangent line in order to estimate the slope. How do you build a tangent line? How do you go from a green line to a yellow line? What you need to do is, you have to minimize the distance between point P and point Q. So that means you have to shrink point P and point Q. So how do you do so? You simply let x goes to 0. So when x goes to 0, approaches to 0, the point Q will slowly shift over to the location of point P, right? That is what do I mean by h equals to 0. So after the job is done, so we go from a secant line, a green line, to a tangent line, a yellow line. So after you shrink the distance between P and Q, the green becomes yellow. So yellow is a tangent line touching the curve one time at point P. So if I know the slope of the yellow line at point P, that slope is the same thing as the slope of the curve at point P. So the limit is, we have to let h goes to 0. We have let f of A plus h minus f of A divided by h. So I don't want to use A, I want to use x. So the limit definition of derivative in the yellow box is f prime of x. Still remember this? This f prime of x. How do we read this? This is called f prime of x. What is prime? Prime means, in calculus, prime means derivative. F prime of x is equals to limit as h goes to 0. We have f of x plus h minus f of x divided by h. So the only difference is I replace A with x. So this one is f prime of A. All I did is I replace A with x. So there are a few different notation for derivative. F prime of x is one of them. Another one that people use a lot is they use y prime. So they use y prime. Another way to express y prime is they have dy divided by dx. So this is dy divided by dx. That is the same thing as the derivative. The first d on top stands for derivative. So here is how we read this. The derivative of y with respect to x. I use the word the derivative of y here with respect to x, with respect to x. What is with respect mean? With respect to x means we treat x as an independent variable. Of course, there are a few more ways to write it. You can write that. You can write the derivative of the function with respect to x. That is the same thing as the derivative of function f with respect to x. You can also write the derivative big D of f of x. So that is the same thing as the derivative. We treat x as an independent variable of f of the function f. All right. Usually people use this notation, f prime of x, y prime, and then dy dx. All right. So let's go over the limit definition of derivative. So as always, I will give you a few examples